Hi, AP Calculus students. This is the worked out problems video for section 4.2. The request was for number 91 and 33, so I kind of got them going here. So the story on number 91 is there is this area of land that was discovered or being sold, and they are trying to get a good measure for this area of land. And this area is kind of bounded by, if this point were the center of a compass here, rather than the origin, kind of has this road to the east and this road to the north, right? And so, and bounded by this really cool stream. Wouldn't that be like up north, like a great piece of property, right? You got your roads and your stream and anyway, I always think of up north. So either to answer the question they are asking on to estimate the area of this land, you could either use the graph that they gave you, or you can use this chart. Now, you would never use the regression equation they gave you, and you never will on the AP exam. And the reason for that is when you write a regression equation for a set of data, then at an x of 10, right, or an x of 170, you could put that x into the equation and output a vertical footage, right? For each one of these x's, you could output a vertical footage, and that is assuming way too much. When you write a regression equation, you are assuming that you know what's going on between these data points, and you will never do that in this class or on the AP exam. So we are left with the graph or the chart, and I like the chart because when I estimate this area using a left-hand Riemann sum, I said left only. On your homework, the numbers are right here for me. I don't have to read the graph, okay? So here we go. Again, these x's go from 0 to 300. Every 50 feet, basically, somebody used a surveying or measuring instrument to measure like the north height from that x, and then took those rectangles and added them up to estimate that area. Okay, so we're going to go ahead and do that left only. Okay, so notice what we have then is for the first rectangle, it is 50 feet, right? If this were 50 feet, it is 50 feet long, and it goes up to 450 and up to 362, right? So we are going to find the area of that rectangle using left only. So let's take a look here. Again, notice that because for each one of these x intervals, each one of these rectangles is 50 feet long. I do not have to keep writing that 50 times the height, 50 times the height, 50 times the height. The 50 is a greatest common factor in each one of the areas of the rectangle. So all I need to do is add up the left-handmost height. So here's my first rectangle with a base of 50. It has a left-hand height of 450, a right-hand height of 362. My instructions are to use the 450. Plus, from 50 to 100, the height on the left is 362, 305, 268, 245, plus 156. Okay, so all I'm going to do is add up all these measures of feet and multiply it by 50. I'm assuming that you can do that on the calculator. I did not ask for right, and I did not ask for midpoint. Okay, what other point did I want to make about this? I know what point I wanted to make. Please understand that the bases of all these rectangles are 50. They're all the same. That does not have to be true for you to find area of rectangles. This could be from 0 to 25, and then from 50 to 100, and then 100 to 110, and 110 to 190. We keep seeing consistently that the base of these rectangles are equal. They do not have to be, that does not have to be true to use Riemann sums. Adding base times height of rectangles is adding base times height of rectangles, no matter what the base is. Anyway, assuming you can do that math right there. Let's take a look at number 33. Number 33 was a picture that they drew. So, and it does say estimate the lower and upper sums, which means left, right. And I also asked you for midpoint. And on 33, the shading was going from 0 to 4. Okay. And let's go ahead and do, so how many rectangles? It says use rectangles of width 1. That's nice. You know, so how many rectangles do I have here? I have 4. So every time I do the area of the first rectangle, the second, the third, and the fourth, I'm going to have a base of 1 times a height, base of 1 times the height. So I don't really need to show that. So really all I'm doing is adding up the left-handmost heights. First rectangle, base is 1. My height, I'm doing left, is 1. Second rectangle, base of 1, height of left, right, I'm using left, 3. Third rectangle, left, right, I'm using left. Fourth rectangle, left about 4.8, and right I don't use. There we go. 1 plus 3 plus 4 plus 4.8. Okay, and I'm sure you can do that math. In fact, I think I actually want to do it though. That's 8, 12.8. Let's do the right hand again for each rectangle. Base of 1, so I really don't have to keep writing it. So I'm just adding up the heights of the rightmost height for each rectangle. First rectangle, height, base 1, left, right, using a 3. Next rectangle, a height of 4. Next rectangle, a height of 4.8. Last rectangle, a height of 5. And we get a total of, let's see, that's 7, 12, 16.8. Now for the midpoint, let's take a look here. Let's find those middle X's. Okay, now please understand that the width of each rectangle is still 1. So I'm just adding up the heights, but I'm adding up the heights that I see at this X. So I'm going straight up and that's my height. That looks to me to be like a little under 2. Again, just an estimate. Second rectangle, right? Here's the middle. When I go up, that looks to be about 3.3. Fourth rectangle, 4.3, just estimating. And then last, about 4.9. Let me just add those up. Got a lot of decimals there, so don't feel like doing the hard work. 1.9 plus 3.3 plus 4.3 plus 4.9. And that is 14.4. Notice right in between the left and the right kind of makes sense with the midpoint. I also want to point out to you that when you look in the book at the actual picture, that they have it on a grid. Like it looks like this. And each one of these grids is 1 by 1. So it's 1 unit squared. And that's what we're finding is the area. And if you actually count up, so what I do is I counted up the shaded boxes, the ones that were fully shaded, right? So I counted up the boxes that were fully shaded first. And then I estimated how many boxes were left that would make 1. I counted this is 1, and kind of a half. And I got 14.5 square 1 by 1 square areas. Take a look. Isn't that about what we found? About 14.5. So when you come up with these numbers for an area and you look at the actual grid and you count those squares, those 1 by 1 squares, really is like 14.5. Just wanted you to know, you get that extra element of logic in there. So have a great day, and I hope this helped.